Hey, MathKook here. This video contains one of many examples in my Algebra 2 library. The rest of those examples, along with hundreds of other videos, are only available at mathkook.com. Let's MathKook it up. Hey Kooks, this question says, find the vertex, whether up opens up or down, axis of symmetry, x and y intercepts, max or min, domain, range, and intervals of increasing, decreasing for the quadratic function f of x equals negative x squared plus 2x. Then graph. All right, so they are asking us for everything for this quadratic function, which hopefully when you see a quadratic function, you know that this graph is a parabola. So here is the information that we need to find. So there's a lot here. So let's start with what form is this function in for a parabola? Well, it's in standard form. So the first thing we want to do is identify a, b, and c. So let's go ahead and do that. So there's a, b, and c. So a is just negative 1. It's the coefficient in front of x squared. B is 2. And since there's no c value, c is 0. All right, next, let's go ahead and start by finding our vertex. So the vertex, the equation to find the vertex is x equals negative b over 2a. And really important, this gives us the x value of the vertex. It also gives us the axis of symmetry, which is a line that runs right through the middle of the parabola. So let's go ahead and find it. So x is going to equal negative b, which is just 2, so we'll plug in 2, all over 2 times a, which is negative 1. If we simplify, we get negative 2. 2 times negative 1 is negative 2, which equals 1. All right, so now we know the x value of the vertex. So I'm going to come over here and write that in. So this is going to be 1, comma, and then we just need to find the y value. And also, we know, while we're here, whether it opens up or down, the parabola. So the parabola, because a is negative, the parabola is going to open downwards. If a was positive, the parabola would open upwards. So because a is negative, we know it opens down. So I will circle down. So we're expecting a parabola that opens downward. All right, so next, how do we find the y value of the vertex? Well, we know the x value of the vertex is 1. So what we're going to do is plug in 1 into our function here to find the y value of the vertex. So f of 1, so I'll plug it in red here. We're going to plug in 1. So we'll plug it in red here as well. All right, so now we need to simplify this. So 1 squared is 1, and there's a negative out front, so it's negative 1. Plus 2 times 1 is 2. So we get negative 1 plus 2, which is just 1. So there's our y value of the vertex. So our vertex is, in this case, 1, 1. So nice and simple. All right. Now our axis of symmetry, remember we said earlier, it's just the x value of the vertex. But really important, you want to write the axis of symmetry as x equals a number because it's an actual line. So x equals 1. So I'll box that there. So there's our axis of symmetry. Very important to put the x equals, again, because the axis of symmetry is a line. Okay, so next, let's go ahead and find our x-intercept and our y-intercept. So I'm going to erase all this information here. All right, so to find the x-intercept, let's start with that. How do we find the x-intercept? Well, you plug in 0 for y and you solve for x. So I'm going to plug in 0 for y in red here. Then we solve for x. So we'll go negative x squared plus 2x. Okay, so everything is on one side of the equal sign, equal to 0. So let's go ahead and factor. What can we take out of here? Well, you can take out an x, and you'll be left with negative x plus 2. All right, so now we have factors equal 0. So we set each factor equal to 0 by the zero product property. So x equals 0, negative x plus 2 equals 0. Then we'll solve for x on the right here. Subtract 2 to both sides. The 2's cancel, you get negative x equals negative 2. All right, and then we just divide by negative 1 to get x by itself. So x equals positive 2. All right, so our x-intercepts are these two guys. Now for any x-intercept, what's the y value? Well, hopefully you said 0, because if an x-intercept is always on the x-axis, which means it doesn't go up or down. So the y value of each of these points is 0. So we'll put that here. So this will be 0, 0 for one of them, and then the other one will be 2, 0. All right, so those are our x-intercepts. Let's move on to our y-intercepts. To find the y-intercepts, you plug in 0 for x and solve for y. So it'll be f of, and I'll plug it in red here, negative, and then we'll plug in 0 plus 2 times, and we'll plug it in red here. All right, then we just simplify. So we have f of 0 equals, this ends up being negative 0 or just 0 plus 0. So f of 0 is 0. So that means the y-intercept is 0, 0. All right, so we'll go ahead and put that for our y-intercept on the left here, which kind of makes sense because if the x-intercept is 0, 0, the y-intercept must be 0, 0. Next, we want to find our max and min. So I'm going to go ahead and erase all our work for x and y-intercepts. So max or min. So we know that in this case, the graph is pointing downward. So let's just draw a quick little picture here. So if the parabola is going downward, that means, are we going to have a max point or a minimum point as the vertex? Well, because it's pointing downward, we're going to have a maximum point. It's kind of like a roller coaster. So this is the top of the roller coaster. So we know it's going to be a max, so I'll go ahead and circle that there. So this will be a max here. And then what is the max value? Okay, so this is something you'll want to memorize. The max value for any quadratic function is the y value of the vertex. So this 1 right here is our max value. So I'll go ahead and put a 1 right there and box it. Okay, so our max value equals 1. Okay, to find the rest of this, the domain, range, and then increasing, decreasing, we're going to go ahead and graph our function. It'll be much easier to find those if we graph our function. So here's our graph. I'm going to graph our vertex, 1, 1. So we'll put that in blue on our graph here. And then we have other points. So we're going to graph our x-intercepts and y-intercepts. So we have 0, 0, and 2, 0. So let's graph those points as well. And if we needed more points, we could always just make a t-chart and plug in like -1 and 3. But I think we have enough points because we know that this point here, 1, 1, is the vertex. We know it goes down like this. So we're going to go ahead and graph. There it is, our graph there. And then I'm going to graph our axis of symmetry, x equals 1, also on the graph as well. And I'll do that in red as a dashed line. So there is our axis of symmetry. Notice it splits the parabola evenly into 2 equal, like, symmetric parts. So we'll go ahead and label that. So our axis of symmetry here is x equals 1. And then this is our vertex, which was 1, 1. All right, so now let's find our domain. So is there any limitations on x here, or restrictions on x? So the answer is no. We can plug in any x value we want, and we will get a y value. Notice this goes to the left forever, so it's defined for all x values to -infinity all the way to +infinity. So our domain is going to be -infinity to +infinity. How about our range? So the range is going to go down forever here. So it's going to start at -infinity, and it's going to be defined, yes, yes, yes. But then the last y value that it's defined at is 1. So that tells us we're going to start at -infinity and go all the way to 1 where it stops. So our range is going to be -infinity all the way to 1. And then are we going to put a parentheses or a bracket around 1? Well, because the point is defined, it's going to be a bracket because it includes the point 1 here, the y value of 1. All right, next is increasing. So increasing occurs where you are going up and to the right. So that occurs all throughout this part of the graph here, from -infinity all the way to here when x is 1. So it's going to be increasing from -infinity all the way to 1. So notice the values in these interval, in the increasing interval, are x values. So that's really important. So it's going from -infinity to 1. And it stops increasing at x equals 1. Then it starts to decrease forever to the right. So therefore, the interval of decreasing will start at 1 and go to infinity because it decreases forever to the right. So the decreasing will be 1 to infinity. All right, I think we've answered everything here. There was a lot asked for in this question. So here are all your answers for this particular quadratic function. Let's look at another example. Hey Kook, if you found this video helpful, hit that like button, subscribe, and drop a comment. For unlimited access to all of my Algebra 2 videos, visit mathkook.com. Thanks for watching.